All right, let's talk about one of the most important jobs in data science, but maybe not the most glamorous one. I'm talking about being a data janitor. We're going to take a messy, chaotic spreadsheet and turn it into something clean and ready for analysis, all with the help of the amazing Python library, Pandas.
So let me ask you something. When you get a new data set, can you really trust it? I mean, if you just jump right in and start analyzing, is that data telling you the truth? Or are there hidden errors, typos, missing values that are secretly messing with your results?
Because look, here's the honest truth. Real-world data is messy. It's almost never clean right out of the box. It's just full of gaps, inconsistencies, all sorts of errors. And that's the big problem we're here to tackle today. So, here's our game plan. First up, we'll dig into why dirty data is such a big deal. Then, we'll get our hands dirty handling missing values. After that, it's all about standardizing the data, and finally, we'll shape it all up so it's perfect for analysis. Sound good? Let's jump in.
Right, so first things first, the problem with dirty data. You can't build a solid house, let alone a skyscraper, on a shaky foundation, right? Well, in the world of data analysis, clean data is your foundation. It's everything.
And here's another way to think about it. Imagine you're a chef. You wouldn't even think about making a gourmet meal with rotten vegetables or spoiled meat, would you? Of course not. It's the exact same idea here. The quality of your insights is completely dependent on the quality of your data.
Okay, time to roll up our sleeves and tackle the #1 problem you're going to run into: missing data. We're talking about those empty cells, those nans that just pop up and can completely throw off your calculations.
So the trick is to have a system. It's a pretty simple 3-step process. Step 1, you hunt down the nulls using .isNull.sum. That tells you where the problems are. Step 2, you have to make a decision. Choose your strategy. And step 3, you apply the fix using either .dropA or .fillna. See? Find it, decide, and fix it.
And that leaves us to the fundamental question, the big dilemma, really. When you find that missing value, what do you do? Do you just toss out the entire row? Or do you try to be clever and fill in that blank with something meaningful?
And that's the real trade-off, isn't it? On one hand, you have dropna. It's super fast, super easy. The danger? You might accidentally delete a huge chunk of your precious data if you're not careful. Then you've got fillna. It saves your data points, which is great, but it makes you stop and think. You have to come up with a smart strategy for what to fill that gap with.
So let's say you decide to fill the gaps. You've got a few different ways to go. The simplest is just using a static value, like putting a 0 where a sales number is missing. A little more advanced, you could use a calculated value. A classic example is filling in a missing age with the average age from that whole column. And for things like time series data, you can do something really cool called a forward fill or a backward fill. Basically, you just carry the last good value forward. Super handy.
Okay, we've dealt with the empty spaces. Our next big mission is all about creating consistency. We need to make everything uniform. That means we're going hunting for duplicates, we're going to clean up messy text, and make absolutely sure our data types are what they're supposed to be.
So first on our hit list, duplicates. Your best friend here is the .duplicated method. Think of it like a little detective that goes through your data row by row. It flags any row that is a perfect copy of a row that came before it, and that before it part is really important. Once your detective finds them, a simple .drop duplicates gets rid of them for good.
Aw man, okay, this is where Pandas is just magic. Seriously, look at this. You can chain these string methods together. In one line, you can take a name with weird spacing and mixed up capitalization and bam, it's perfectly clean. Being able to chain these .str methods is an absolute game changer when you're working with text. It's so powerful.
Next up, data types. It sounds basic, but it's so important to make sure your numbers are actually numbers and your dates are actually dates. For the simple stuff, .astype is your workhorse. It'll get the job done. But when it comes to dates, dates are tricky. They come in all sorts of crazy formats. That's when you call in the specialist, pd.toTimeTime. It's incredibly smart and can usually figure out what you mean, no matter how weird the format is.
But what if you need to do something totally custom? Well, you've got a few great tools in your toolbox, and it's all about picking the right one. If you need to run a complex function on a whole row or column, .apply is your flexible powerhouse. If you're just doing a simple one-to-one swap, like turning an M into male, .map is super fast and efficient. And if you're just fixing a few specific typos, like changing del to deli, .replace is perfect for that surgical strike.
All right, we are in the home stretch now. Our data is clean, it's consistent. Now it's time for that final polish. We're going to sort it, rank it, and restructure it to make sure our data frame is perfectly organized and ready for the fun part, the actual analysis.
Sorting seems basic, but there's a key distinction here. With sort values, you're sorting based on the data inside the columns, right? Like listing employees from highest to lowest salary. But sort index is different. It sorts based on the row labels themselves. This is really useful for getting things back in a nice, clean order after you've been dropping rows and moving things around.
Ranking is another super useful trick. Now check this out. By default, if you have a tie, like these two scores of 95, it averages the ranks. So they both get 1.5. The next score then gets rank 3. But look at the dense method. The two 95s both get rank 1, but the next rank is 2. See that? No gaps. This is just perfect for when you need to make something like a clean leaderboard.
And for the finishing touches, let's get that structure just right. We can rename columns so they make more sense. We can reorder them to put the most important stuff first. And after all the sorting and dropping we've done, a little reset index function cleans up the row numbers, giving you that perfect sequence starting from 0. It's like putting a bow on top.
And just like that, we've done it. We've taken a chaotic, totally unreliable mess of data and transformed it into a genuine asset. Something clean, organized, trustworthy, and ready to start telling you its secrets. So, the data janitor's work is finished. All that cleaning is done. Think of your data now as a perfectly prepped blank canvas. The only question left is, what story are you going to make it tell?